You're live. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Blast off. We have connection. The internet seems to be showing up. What's going on, Adam? I have to say yo, and I also have to say I don't know how long the internet is going to hold up here. If you can peek back, and I'm going to zoom in here, and you can see I have a couple of things going on back here. Let's start off with one. Yeah, pretty grainy, huh? One is there's my oscilloscope. That coil. Then in the far, let me see, where's my finger? Finger. Wow, you can't even point a finger. Very grainy. Adam, can you see the laboratory, man? Hello, my fellow YouTubers. So here I'm outside the zone of the, we're going to call this the Monkey's Garage. I like that. Beer goggles. How about now? Does it look better? Alrighty, let's see if we can move on in without losing each other. We are in the, how's it on this command? Yeah. All right, I think I'm back. I haven't moved. I'm just in the chair. So, this is a bunch of BS. So, the next time I do this, guys, give me about a week. I know. So, I'm going to change out my Wi-Fi, but I'm going to bring it. My son plays a lot of games, right? Yeah, I'm back. So anyway, so my son plays. Both of my sons play a lot of games, but my oldest son has this thing that you plug into the router and plug into the wall outlet, and anywhere in the house, you would plug into the wall outlet and you would have the Wi-Fi in that location. Crazy strength. So I'm going to go ahead and do that. I think it's really exciting to do this. I love this live because what I really want to do is just hook it up to like telephone too, to where we can actually talk and have conversation and people can listen. So right here I have these super caps. These are 1 farad each. There's 9 of them. 2.7 volts. All right, Adam. I'll check it out, but we'll get this whole internet thing in my workshop super strong. Trust me. We'll get it going. So you got super capacitors there. And I was just thinking about that, and I've been taking my DC generator, my DC power supply, and charging my capacitors there, and it takes a while for those to charge. So I've been playing with changing the amperage and the voltage and trying to see what speeds up the charging, and so far I blew a lot of them. But I have 9 left. Go figure. So why am I talking about these super caps? Anybody have a reason? have an answer? So, if we were all looking for what? Free energy or energy from the ground? Well, buffer's good, Adam. That's a good comment. But, buffer, if we were all seeking to find energy to use out of ground or air, we all seem to have missed something. And I think we could talk through the something that's missing. What do you guys think? Who's out there? Give me a shout out. I got 3 people watching right now. So we got Adam. Give a shout out. Adam, do me a favor. Do me a favor to paste this and post it. So when it appears, it shows up. Everybody can read the comments, all right? Yo. I like that, Adam. So we got Adam as a yo. Who else? Somebody else. We got 2 invisible people. Yeah, only if the video stays going. You know, this is weird. Hey, David. All right, I got David. Yo, big guy. I got David in the house. I got David and Adam. So, Terry Woodruff. What's up, my buds? Terry. All right. I got my 3 masters on the phone. So, guys, man. Hello, hello, hello. I almost feel like we should be in a room that we all can talk. Because if we could all talk together, it'd be awesome, huh? So here we're dealing with, I'm electromagnetic, okay? And not to make power because, yeah, cool beans, Adam. Cool beans, thumbs up, David. Not to make electromagnetic electric how we do electric today. So here, this whole thing is different because it's about making that thing right there, the PMH, make that thing turn. That thing that's electromagnetic because of each field has a concentrate from one magnet down to each one, right? It's like eddy currents in a sense that are being, my finger's screwing up. Oh, there you go. Get my finger out of it. It made everything blurry. I just realized that. Sorry, guys. So each layer of the magnet is a north. So it's just, say if this is a north. So the whole thing, because they're layered, will come out and go around and go back to the bottom. And I sort of showed, where is that sucker? Oh, hell. Hope I don't lose you guys. I didn't mean to move. Bad Roy. Bad Roy. All right. I showed the field. And the reason I was even showing the field is because we don't get to see this stuff. So using the right-hand rule and just using basic stuff that we know about how magnets react. Here you got your north is always going towards the south. Your south is always receiving. So you got a receiver and then you got a transmitter. So just remember that. You work in Tesla coils and you got your little receivers and transmitters. Remember that. That's your transmitter energy going out and that's your receiver energy. It's always receiving. You guys got any comments? Please do leave comments, man. I love this YouTube stuff. I love Terry, man. Terry, please show me how to do your vacuum bottle. I haven't really tried to get into it, but it's so cool to see 2 probes in a bottle or 2 bottles stuck together. Email me, my buds. Vinny St. Vincent at AOL.com. The funniest thing that ever happened to me was yesterday. My wife texted me. Well, thank you, Truth Seeker. And David, Well, it could do both, David. So basically, David's leaving comments, and Truth Seeker left a comment. So I'm kind of reacting to comments that the rest of you guys can't hear. Hopefully, you can see the comments. Yes, transmitting to receive. Exactly, Adam. So just like this, if everything is coming out of the north, you're pushing out. So every time there's an explosion, say a Tesla coil, and it's got its cycle. So every time it's cycling up and then cycling down, the same things happen here with magnetics. So here you got your going out, and then as your transmitter, and there's your receiver. What's cool about that is today I woke up in the morning and I was fascinated about this pipe. This pipe. Exactly, Adam. Your comment you just left about receiving and going out on an antenna, that's a dipole antenna. And that's what it takes to send it out, because what you do is you have a length, and say you whip from the bottom of my thumb all the way to the top. That whip goes out. So that part of that north and that south there is the wavelength right there. So that wavelength right there would be what's either being sent out or being received. So you would definitely have the flow, the current flow of the magnetic field of these magnets. But then you would also have the dipole, because like on top of Ed's house where he lived, where he slept, he had wires up in the ceiling, and there's like he had, of course, he had coral rock as a roof. It was about 6 inches deep and a good sized slab. So he was pretty good at pulling layers out for some reason. And that can't be easy to pull those layers out. But anyway, he had wooden round dowels that were probably 8 inches diameter, so tree trunks. And they were running across to support the top. And he had his wire up there still. And the wire goes all the way, and it stops at a circle right above his bed. And it's got crosshairs in the circle. And you can see out the crosshairs. Well, the position in the hole in his ceiling were crosshairs. You know, what? Who knows? I don't know. The crosshairs mean something more than I would think of. But basically, there is a ladder that goes up on the side of his living quarters from the ground. It goes from he walked up on top of the wall. He walked across the wall, climbed a ladder to his roof, got to his roof. There was an antenna. So the antenna, I believe, was part of the one signal, the ground pipe we're talking about here, my new fascination, the ground pipe. What do I like about the ground pipe? Guys, please read. Yeah, it is. So the antenna is critical, and then also this is critical, is the pipe. The fact that the pipe is metal. You know why the pipe being metal is important? Anybody out there have a comment? Why is that pipe important? Anybody have any comment right now? All right, so we have Adam. All right, but we're talking about antenna in reference to that ground pipe. No, yeah, I'm going to say, listen, the pipe is an antenna. It's the other pole of the dipole. All right, guys? The other pole of the dipole is that antenna. But let me tell you what else it is. It is a waveguide. The pipe is a waveguide. Does anybody know what waveguides are? Come on, guys. Spit it out. Anybody know what waveguides are? In microwaves, waveguides. Leave your comments. Waveguides. Come on now. Yes, it does. Waveguide sets frequency and transmission. That's what that pipe is, guys. Yes, Adam. A resonant cavity. That's what that ground is. Ground is the most important thing. You know why, guys? Why is ground the most important thing? It's connected to anywhere. All of us is connected to ground. All of ground, we're all connected. Do I get a thumbs up? Do I get a thumbs up? Are we all standing on the same freaking ground? Thumbs up. All right, good. We get thumbs up. Thumbs up. We're all standing on the ground. So what if we put a resonant cavity in the ground like the pipe and we talk to each other? Is that not doable? Is that not doable? All right, good. I like what I'm hearing out there. So listen. So I was experimenting today. And the funny story is yesterday my wife calls me and says, honey, I was at work. And she says, the power's out. And I heard a bang in your workshop. Were you doing anything in there? There you go, Terry. One big conductor. One thing I like about the pipe, now think about this. Leedskalnin, from 1930 till 1950-something when he died, and then Tesla's death. Leedskalnin's hero probably was Tesla. And Einstein, and also Edison. All right, so let's get in that atom. So we'll go back to the pipe. I'm sorry, guys. I got a little pulled out. The pipe is a longitudinal waveguide. A longitudinal. So guess what we're doing? So listen, so these are longitudinal waves. So if we were going to set a frequency of a certain voltage, and listen, don't look at Ed's wheel with the magnets being like neodymiums. They're not. It's more about what Ed learned through the process of all the fundamentals of what he talks about in his magnetic current, a book in every home, animals, minerals, and planets. These are the books that tie all the stuff together because he's all over the place. Sort of like me. Longitudinal waveguide right there is that pipe. Sweet 16. Truth Seeker in the house. What's up, buds? So, well, scalar waves, dielectric, longitudinal waves, cold electricity. Whatever you want to separate it, it's all here, guys. Whatever you want to create is here. Because it all takes one spark. And using the Model T, you can increase the voltage You can increase the amperage. You can make what you want. And then you got frequencies from the pulses of the wheel. Back to the longitudinal wave. So let's not get so sidetracked. So here you go. So the pipe becomes a resonant chamber, guys. Here's what I want to show you guys. Let's turn this thing on. All right, so we're going to put on this oscilloscope, and let's go ahead and connect it to, let's turn this on. All right, just bear with me for a second. I got to connect this to this. How am I going to do this? Let me see. So we're going to get the oscilloscope going. And we're going to run a frequency from the generator, the signal generator. And what we're going to do, the frequency, we're going to do the Schumann resonance of 7.83. Okay, guys? And we're going to talk about turning edge wheel and getting to that frequency. Okay, so right now we have just nothing going. You have to turn this guy on. So far that ain't going on. There it is. Oh, I gotta, I got a plug that's not liking where it's sitting. Where are you, plug? Is it that one? All right, we're on. Fire and all. So right now we're gonna change. We are in hertz. Let's go kilohertz. So we're gonna go over 1, and we're gonna get rid of that. Gone. So we're gonna go over. We're gonna change this to hertz, and then we're gonna go over to 7. 0.83. What just happened? Oh, we're in kilohertz. We gotta get that back. 7.8. 7.83. Okay, so now we're pushing 7.83. Okay, guys. Now we're going to go over to the oscilloscope. Let's turn a little light down so we can actually see it a little bit better. And let's go ahead and make some adjustments here. So we're going to, that's the length of the wave, and we're going to just go to the, let me see, we are at, no, we're at kilohertz, hertz. Now we got some, can you guys see it? We got some malfunctions. Let me change the numbers. And we're at 7.83 now. Okay, 7.83. Now we're seeing a wave. So this is the wave. I agree with the electrostatic capacitors, and we're going to get into that. This is the wave that is the Schumann resonance. I want you to look at the hump, and let's go ahead and let's tighten it up a little bit, okay? And then let's go ahead and bring it a little bit shorter. Do you see that? Do you see that wave? That's our wave right there. That's the profile. Let me turn that up. Sorry, guys. All right, here we go. So, and then so I'm going to leave it a little bit long, okay? So this is the Schumann resonance, okay? So look at the wave front, guys. I want you to see this. It sort of looks like if you were to take a blanket and shake it and it goes up and down. Look at that wavefront. So this wavefront is what we're trying to, yeah, it's like a ping pong. That's right, Tommy. It's like a ping pong. You can see, but let's go ahead, and that's your middle line right there, okay? And let me go ahead and, no, we're set pretty good there. Let's go ahead and beam it in. So I want you to look at it in the beam, okay? So there you go. Now, what I want you to see in that beam, can you see that, guys? You see how you were flopping left to right on that beam? So what we're doing with that Schumann resonance, we're shooting from the upper ionosphere to the center of the Earth. So from the center of the Earth down to the ionosphere down below, guys, is doing the opposite of what this wave is doing. Think about this. Think about what's happening. The equator of the Earth has this wave on the top of it. It has the opposite wave on the bottom of the equator. Yo, yo, yo! Got Adam and Tommy in the house. My boy Woodruff, you still out there? I can't believe I'm getting reception tonight. It's one of those nights. It's a night to be. My boy Terry Woodruff out there. Give me a thumbs up, Terry. Man, I love your work, buds. Schumann resonance. So how do we accomplish getting the Schumann resonance over here on this guy? Think about this as a waveguide. And we're only doing 7.83 beats. That's right, Adam. Let's go take a little walk outside. I want to show you guys something. It's a great, beautiful night for stars. And let's take a peek up. Let's see if you guys can see any of the stars. I don't know. I'm looking up in the camera. I see the stars, but I don't know if you guys can see them. Black as the night, huh? And I can see these stars all out there. Down here in the Florida skies. That's amazing. Can't pick the stars up. So whatever we do digitally here with these cameras, the stars don't really come in, huh? Let me see if I can zoom in. No, nothing going on. Okay. I'm gonna go back in that. We got Vinny over here. Uh-oh. He's protecting my workshop. Vin, everything good? Good boy. Alrighty. Yeah. All I gotta say is my power went out. My wife called me, told me the power's out. My workshop sounded like a bang came out of it. Getting back to that story. So I come and I said to myself, the only thing I have running was my oscilloscope, my frequency generator, and I had a coil in the pipe. Think about that. My wife texted me and said 23 houses were out of power. I don't think it was me. What we live on, our panels are so closed circuit, separated. But it's pretty funny how you come to my workshop and I got this Schumann resonance beat going. Only 10 volts. I'm only putting out 10 volts. I got no amps on this. So the pipe is not getting much of anything. But just, it's funny how that came about. Really, really, really funny. So, yeah, funny story. It was out of power. So what I did was, as I was out of power, I got my 2000 watt inverter. Got my batteries going, had my lights. House is out of power, and I just kept working away in my workshop. Nobody was home. Everybody was in school. Funny stuff, huh, guys? So the fact that we still have internet, I am blown away. I can't believe it. Yeah, we're going to go with that Nichrome camera, huh? All righty, so let's go back to this Schumann resonance. Here we are banging some Schumann. So let's go ahead and spread it out a little bit. One thing I wanted to show you is if you look at this now, this is almost like if you would take a rope. And these are the next, what is this in? This is in almost at 0.2. So this is almost like a jump rope to where you actually have almost like the fish for some reason, huh? The Jesus fish. And then you go back, and then you look at the linear part of this wave, and I want you to see, we'll just keep it separate like that, and we'll go beam it in. I like that the best, the hump, because you can see it, and that's the middle right there. So that would be the center of the Earth. That would be upper ionosphere. There's the wave we're looking to use as a carrier wave, all right? What the heck? What am I talking about, carrier wave? Well, there you go. There you go, carrier wave. So if we were wanting to do something with the carrier wave, what part of this wave would be, leave your comments right now, guys. What part of this wave, if you wanted to send something, what part, where would you jump on that wave? Come on. I don't see no comments yet. If you were to get on that wave and you wanted to go somewhere, what part of that wave are you going to get on? The opposite. I don't know where you're talking about. So you want to be in the front of the wave. Is that what you're saying? No. Let's think about the Tesla coil, guys. On the Tesla coil, when the wave builds up and collapses. So basically you have the downslope, David. All right, David. So listen, think about this on this wave. This is the Schumann resonance wave. If we want to send something out, we would want to be like a kid on a swing, to where the kid goes up, comes back, and then starts going forward, and then you push them, right? Do I get a thumbs up, guys? I like your comments you guys are leaving. Love them, love them, love them. So, there on the wave is where you want to be. So obviously as the wave is traveling forward already, so you want to be on the part to where it's continuum, okay? So if you look at top and bottom, and there's your peak, let's make the spans, let's bring the time in a little bit. Let's get the peaks closer. Let's make the peaks closer. So let's see what we got to do here. All right, so there's your peaks. So we're making time less, and there's your peaks from peak to peak. So there's your wavelength right there, guys. From peak to peak is your wavelength. So if we're looking at one square versus another square, look at your wavelength right there. So on your wavelength, we want to be able to be on the downside of that line on the front of the wave to be pushed forward. You guys agree? Thumbs up. Do I get thumbs up? Anybody? All right. So now we got passive transmitting. Let's go to receiving. So if you were to receive something, you wouldn't want to be on the front side of the wave, would you guys? You want to be on the back side. You want to be on the part from the bottom that's swinging up, right? So around that line right there from the valley, 90 degrees. There's your 90 degrees. So you want to be a little bit up, so you're being pushed. So that power, data, or signal is being pushed into your system, pushed into your coil. Pushed into your coil. You guys get that, right? So Schumann resonance, there's your energy, guys, right there in the planet. There's your wave that's going by every one of us right now. Every one of us right now, where we're watching me, is getting this wave going through our bodies. Think about that. Through our bodies right now. This wave is bouncing through all of us. So if I want to think of something right now and send it to you, if you were in my tuning, receiving of thinking, you would get it, right? Come on, guys, right? I know we're a little delayed. Leave your comment. If I'm thinking it, you guys should almost get it based on this wave, right? You guys should get it. If right now, if I'm not thinking of anything, I'm not putting anything out there, but I'm going to do it right now. And I'm going to think of a person. And I'm going to put it out there on every time I see the light go by on this frequency. I'm going to think about it. You guys ready? 10, 9. I'm going to think of a name. 8, 7, 6. It's going to be somebody in physics. 8, 7, 6, 5, 4, 3, 2, 1. Put your comments out there. Right now I'm sending out a signal. I need some more comments. I need some more comments. I do like Maxwell's Smart, by the way. I like the doors. Adam, you're throwing some good ones out there with the Farnsworth. I guess we're going to have to work on this one. You guys, none of you guys got it. And I'm not going to tell you who it was. It was simpler than that. But we're going to have to figure that one out. How do you transmit? This wave is going by us right now. Think about that. I could almost feel it going through my blood right now, my body. And you guys should be able to feel it too. So how come we're not connected mentally? How come we get a buzzing in our ear or something when somebody's talking about us? Why aren't we tuned to this in our brain capacity to connect? Leave your comments, guys. I would think that, Adam, you got a good thing there. We're not grounded. I should almost be barefoot. We should do this as a test in the future, unless you want to do it now. Do you guys want to take our shoes off and go bare feet and try it again? You want to try this experiment? Ground it, touching the ground? Damn, Tommy. What the hell, man? All right, I'm taking my shoes off, taking my socks off. All right. Jesus, you guys are cool. I like this. All right, so look. Freaking, there's my foot. Got to take my other sock off somehow. And this is great because, all right, there we go. All right, guys. So I'll get my feet on the ground. All right, feet on the ground. I'm grounded. I got my hand on the phone. I'm going to think of somebody, and I want you guys 5, 4, 3, 2, 1. Dude, you're so close, Adam. You're so damn close, Adam. Adam, Alexander Graham Bell, you're close. You're close. You're no cigar, but you're close. No, you're even closer. You're close. I'll give out a clue. He wore a wig. Yes, David. My boy Benjamin Franklin. So we're going to have to work on this transmitting. So let's get back to electronics. So with that wave that we have going through us, if we use the pipe as a waveguide and we're wave guiding that signal, you should have been holding the key, Tommy. If we're wave guiding 7.83 hertz sine wave into the pipe, at some point we should be able to tap the right spot. You guys agree? So high voltage to ground, meaning we're just going to take a step up transformer or a step up inductor to be tapping off the wheel. I mean, think about the Model T parts to get the spark plug going. Oh, for telegraphy. No. Let's just say this. One thing I didn't mention about telegraphy with us, the next video we're going to do is the pineal gland. I'm going to give you guys a lesson on how to tune into your pineal gland. You guys want to do it now? Hell. I get any thumbs up? Anybody want to do your pineal gland now? Barefoot to the ground? All right, so here we go. So get your bare feet. Let's do this. We're all barefoot, so we're all connected. Listen, every one of us right now is on the half swing of this, okay? We're all connected to the bottom. We just have no connection up top. Tommy, not the electrical wall outlet. Do your feet to the ground. Now think about this. There's your middle wave. There's your descending and there's your rising, your peak. Hey, we should all be wearing aluminum hats. So we're all connected on this part right here. So right now, we're going to try to connect here through our brain, okay? I'm not saying I know about this. I'm just saying we're going to try this. And basically, up here, each one of these humps could be a person. So what if we wanted to connect, if we're all connected down bottom already? So let's go ahead and do this. Think about your brain behind your eyeballs. All right, guys, listen about what I'm going to say. Focus behind your eyeballs where the back of your upper bridge of your nose is. Listen, both your eyeballs together behind the bridge of your nose, focus on that. That, you need to focus until you feel it vibrate. Now listen to what I'm saying. My eyes are closed right now. And just focus behind your eyeballs, back behind your nose back there, and that until that vibrates. So basically what you might have to do is tense up in the brain and get that part to vibrate. Now, once you get it to vibrate, it's almost scary because you can do too much and you almost feel like something strange is going on, or you can vibrate it less and sort of back out of it a little bit. I call it like, sort of like a drag. Like if you were back in the day, a DJ with an album, you would slow the speed down by putting your finger on it and dragging it. And that's what that vibration is. I think it's a... So get in there to where you feel it vibrate. Now I'm going to go ahead, if you guys are in there, and you're focusing hard, where it almost like you feel heavy in your head. You feel that, guys? It's just like, ooh. I'm going to go ahead and think of an object, and I want you to go ahead and feel the object. It should be vibrating in your head. Feel the object. Type it in what you feel. Type in what you feel. It's an object. All right, so I'm going to say there's a yeah, Adam, you're close. Adam, you're close with the pipe. Thinking of a bell. Thinking of a bell. We need to do that at some point, guys. This is pretty good experimenting. Pretty good experimenting there. Because I think it's all in the brain. Eventually, we'll figure out how to tune ourselves. Trust me, we'll figure out how to tune ourselves. So anyway, Yeah, man. We're back to the things. So I brought out some things I wanted to talk about. This is magnesium. This is brass. No, actually, that's tin. This is brass. Then we have iron. So now we're starting to think about things that are going to react. That right there. We're talking about elements, metallics, that will react to that signal. Anybody got an idea what I'm getting at right now? Anybody have an idea? Chunk of iron. You got magnesium, iron, tin, brass. Hell, we might as well throw some copper in the mix. So there's the copper. Here's some aluminum. The question is, why am I bringing these objects, these elements up? Why am I digging in to the periodic table? Well, why am I doing this right now? We're talking about Fe right there, iron. We're talking about nickel. We're talking about bismuth. I didn't even bring that one out. But these guys right here have something to do with Wilhelm Reich. Does Wilhelm Reich ring a bell to anybody? Is anybody familiar with Wilhelm Reich? All right, good. So we got some Wilhelm Reichians out here. So with Wilhelm Reich, we're going to talk about electrostatic real quick, because it's the electrostatic induction of bringing one element next to another. And say if this is positively charged and this is neutral and this is negatively charged. So this one here that's positively charged, we're going to bring close to that iron. What's going to happen is they're already reacting right now. The negative ions from the magnesium is being pulled into the iron. The iron has already attached itself atomically in front of our eyeballs, and they're not even touching. So now all those negative ions are pushed to the opposite side of the magnesium right now. And the opposing field is to the opposing field on this side, which has moved over to here. So if this is the positive side, this is the negative, this would be the positive, that would be the negative. And then we're going to bring the the tin over. The tin's a neutral. All of a sudden now, because of the overabundance of negative ions that came from the magnesium, was abundant in here, which shifted to the backside, and now the backside will push its negative ions over to the neutral. The fact that this piece here collected energy in front of our eyeballs by just being close to these in proximity means what? Leave your comments there, guys. Come on, give me your comments. It means what? We're moving energy right now with atoms that are still. Think about this. So, what we're talking about here is you create current of negative ions. If you want to call them electrons, call them electrons, but there's no electrons in my head. You're creating current by knowing what material to put in what place to move. It'll keep going. It'll keep moving through the matter. Keep flowing. You're creating basically a wave through these atoms and these materials. You just have to know what material, its density, its atomic spin is very important. We talked about that. Here's your atomic spin. Here's Ed's wheel. So the atomic spin right here is if we're pushing out from the north and heading to the south, this is a great lesson here because this is what we're talking about. So if you're pushing out from the north and heading to the south and the energy is running this way, if you go with the right-hand rule, your wind on your coil would be this way, fingers towards me, and the current be running that way. So your spin is going this way, okay? Right there, your spin is going this way. So there's your spin. Now, you have a spin that's going on between the north and south, which is going this way. So think about this. This becomes a gyroscopic event right here because you're coming out, chasing the south. You have a rotation of going that way, okay? Yep, no, you're going that way. So there's your rotation. You're spinning. Yep, you're spinning that way. And then you got your rotation up top. You can see everything moving and the direction of everything. And it keeps the same thing. Like over here, here's your north chasing this south. So it's the opposite side of this south. You got north and north. So everything is coming backwards on the opposite swing. So now you have the north coming this way. So you're going to have your spin is going to be, your coil is going to be running this way. So your spin is this way right there. And then your movement between your north and south is running in this rotation right there. And then this one's running the opposite rotation. Pretty cool stuff. I mean, if you think about magnets in itself, it's like I always been interested in magnets. And if you think atomically how these work, then you start getting into Wilhelm Reich stuff to where you say, okay, well, Wilhelm Reich stuff is about taking different parts of the element and putting one in front of the other. But I think the key is this. The key is this can't just be not only close, but there needs to be a dielectric film in between the materials. So they are so close together, but there's a film in between them. And this is something I want to talk to you guys in regards to Tesla talking about slack spring capacitors and also talking about this guy, this professor from 1969. And his name is Julius Sumner Miller. You guys, check his videos out. Go to my favorites. You'll see him popping up there. He's got 47 good lessons from 1969. So he talks about he blows a big bubble and he blows a little bubble. And he talks about which one do you think would have the greatest pressure. So here's a question for you guys for tonight. If you blew a big bubble right now and small bubble right now, 10 times the size. Here's your small one, 10 times the size. Here's your big one. Which one has more pressure? Leave your comments. Two bubbles, one huge, one small. Which one has more pressure? Any comments? All right. So it's the little one. Everybody would think the big bubble. It's the little one, only because it's got a smaller surface area. So it makes you think about putting a dielectric in between elements that I would say are close to each other in the horn of elements. So if the elements laid out on a chart was set up more like a horn, the space inside of it would be like a middle of a hurricane where it's calm, and the outside of the horn would be where it's catastrophic craziness, destruction. The black hole would be outside the horn, not inside the horn, outside the horn. It's the dielectric in between the materials that will cause an enormous amount of striking power of the negative ions based on what their element is. And in order to get this magnesium to release its balance, balance, and balance, and balance. So if we were to unbalance each thing, say if we would touch ground is what we would do. Ground on that, ground on that, ground on that, ground on that, okay? So they're all balanced. Now, we take this and we put it near electrostatic and we charge it. We charge it positive. And we put it near here, and this neutral right now is all whacked out because it's getting sucked into these molecules, which are now positioning themselves to come to war to this one. Then this one is going to do it to this one. This one's going to do it to that one. Now you have a dielectric snappiness in between these elements. But how do you pulse them? Any comments, guys? What do you got? You got anything for me? How do you snap? How do you take balance to unbalance and make it oscillate, if you want to call it oscillation? How do you get it to transfer and move the energy? Any comments? We're talking electrostatic right now. Do I have any electrostatic guys out there? Electrostatic. Skin surface. Ring a bell? Lord Calvis. Yeah, I like that one. You too, Tommy. Build. Well, with the Calvin. Mr. Calvin, huh? Think about these things that are sitting here right now. Do you think they're being affected at all through a solar storm? Any comments? Do you think a solar storm right now is affecting anything in these materials? Guys, do you think solar storms are affecting these materials right now as we speak? Are they being affected through that wave right now? That Schumann resonance. Schumann wave. Are these being affected right now? Sure they are. Ask me, why is solar waves important here? Think about what I'm saying. Solar waves, meaning flares that are constant out of the sun, that are abundant more than a constant. The solar flares give them their oscillation. They're oscillating in front of us. We just don't even know it. The air is so counter-reactive. It's amazing. That Schumann right now that's going by these waves are causing the sides to flip. Wherever everything sits is moving. So, Marker, we'll get into some thermodynamics, because thermodynamics is the root of all of it. Thermodynamics. Battleground Z, he says. That's right, Tommy. So thermodynamics, we're talking about the constant barrage of solar energy hitting the planet, and it's causing elements to react to the constant, which is like a dead short. So it creates heat on all the elements, It's like a dead short. Except the mass of our planet is enormous. It's amazing how it could suck hot into the ground. The ground is a heat soaker. I'm just going there. It's a heat soaker. It pulls in the thermodynamics of the jet streams and the Venturi effect with the Bernoullis. They brought us the Ventura effect, which is the upper jet stream traveling at a speed which causes an updraft of dust particles coming up from the ground into the air. Think about that. Think about electrical storm that's getting sources of energy of dust particles. That's enormous. Alrighty, I guess we have to check out. I'm being paged to 69 minutes. I can't believe that I took up that much of you guys' time. And hope you guys enjoyed the conversations. Adam, do me a favor. Post up the comments for me, because I can't do it. It'd be nice to look at the video and see everybody's comments, because I didn't catch them all. To the Schumann residents. Peace out, my brothers.